Professor of the University of Miami School of Medicine. This is a YouTube presentation on climate change, the hoax of CO2. This will be a preamble to what you're going to view over approximately 10 different segments. This is based on Climate Change, a Hoax of CO2 Revealed, my latest book on how climate change really occurs and that CO2 has really nothing to do with climate change. The book will tell you that climate change is real. It's advancing slowly at the rate of 1 degree Fahrenheit per century, different from what your politicians are telling you, and that the sea level rise is not due to melting of glaciers. Now, that may be in confrontation with what you're hearing, but stick with this, and I think you will find some interesting data. Now, this is how you can order my book. I would please if you would. And then as we start this, I will show you that there is my uh, email address and my phone number, as well as the publisher. We're open for questions and challenges. So this is all really transparent, things that politicians talk about, but very rarely do. For this segment, we're going to explore the question of, can electricity replace fossil fuels for cars and trucks? Now, we're going to break this up into two segments. The practical limitations of electricity for replacing fossil fuels in cars and trucks. And then probably the more important one is the scientific limitations, which is really going to limit what applications an EV car or truck can really provide for the public. All right, let's begin. Most EV cars cost 5,000 to 40,000 more than gasoline cars. That's significant. So this is why they're not selling very well and why several states are pulling back on the EV mandates. It certainly is something that has to be affordable if it's going to replace gasoline and diesel power. Secondly, EV cars cost more to insure, for sure, maintain. Oh, you might want to stop me there. Maintain? Well, a gasoline powered car, you have to change the spark plugs, the fuel injectors, oil changes and such. But those are relatively minor costs. The big costs are transmission. The biggest cost is the battery, of course, and of course, a differential. Any part from an EV car costs more to purchase and more tricky to put in. Labor is higher. Okay, to continue on, EV cars cost more to insure, to maintain, to repair, and more to replace the tires. That's becoming a bigger and bigger issue as we proceed. And here's some EV tires. You can see some horrible wear on the left side and some wear on the right side. But these didn't go very far. The tire changes have to be done with EV cars, depending on how heavy the battery is, every 10 to 18,000 miles. Whereas a gasoline powered car, you change the tires about every 40,000 miles. So this is a significant cost and a significant safety and pollution issue, actually. Okay, so take the Tesla as probably the epitome of an EV car. The battery weighs 1,864 pounds, which causes excessive tire wear. Even the smaller EV cars like the Chevy Volt, the batteries are 1,100 pounds. That's like having four middle linebackers sitting in the back seat of your car. And that's before you put any cargo or any people in your car. Now, a Tesla's a pretty car. It certainly is clean. It certainly looks very elegant and it's certainly quiet. There's an attraction to EV powered cars, but at what price? Batteries for small EV trucks, such as airport shuttles, weigh more than 3,000 pounds. If you put in an electric vehicle such as the Amazon or a United Parcel Services trucks, those batteries weigh anywhere from, again, 1,800 pounds to 3,000 pounds. And that's the underlying limitation. So EV cars and small trucks add more pollution due to a 20% to 40% faster tire wear. Now, how does that relate to pollution? We're not doing any exhaust, it's producing a CO2 or carbon monoxide. It is the particulate matter, basically the microparticles from tire wear. They eventually get into the water system and flow to our oceans. It has been estimated that 60 to 80% of the microparticles that are in our ocean today come from tire wear, and the EV cars produce much more. So changing a worn out battery is also very expensive. It's at least $10,000 and up to 20,000 depending on how big the battery is. Tesla versus a Chevy Volt or something like that. And you need to remember that it 500,000 tons of earth have to be excavated to produce the trace elements that are required in the battery, like selenium and cobalt and other such rare earth minerals. And that's why most of them are done in China, which don't care, and why we have very little done in the United States and why the cars are so expensive, because we have a sense of conservation and care for our environment. Now, charging stations, too, as of today, they're few and far between. And you have to remember a full charge is not 100%. It's defined by the government as an 80% charge. I was surprised to hear that, but that is true. Now, what happens if you run out of electricity? You're in traffic and you're on an expressway, you're stuck. You have to get a tow. If you're in a gasoline powered car and you happen to have the good sense that, well, there's a lot of traffic, I may run out of gas. Don't forget, you can go much further with a gasoline powered car. And you keep a quart of gasoline in a gasoline container, you can get to the nearest gas station. So there's not much backup that will save you from running out of electricity in the middle of a long stretch or in the middle of a traffic jam. Not all public charging stations are superchargers. They take about 30 minutes to charge, whereas an intermediate charger is about 7 hours to get the 80%. And the overnight charger that you will have in your garage is essentially a 12-hour, maybe 10-hour charge. So that's an overnight type of a charge. So if you're going to a public charging station and there's somebody ahead of you who maybe just started, he's got 15 to as much as 30 minutes before you can even begin your 30 minutes. So you're going to take a fair amount of time with charging your vehicle. Okay, home charging stations. Now, if you have an EV car, you're going to need to have a home charging station, and they cost between $1,200 and $3,000 to purchase and install. Now, if you happen to be your electrician, it's going to be much less, but most of us are not certified electricians and are going to have to pay someone to install it, hook up a 220-volt line, and purchase it in the first place. Now, EV car owners have to realize that they're not saving the planet. One of the early pushes on EV cars is that you need to be a good steward of the environment. This is your contribution to saving the planet. The answer is you're not. You're buying a nice looking car. You're buying a quiet car. You're buying a clean car, but you are not saving the planet. And here is why. Not only do you have toxic pollution from the excessive tire wear and the fact that the tires produce a more toxic microparticle than does a tire that is built for a gasoline powered car, but 80% of the US electricity grid currently comes from fossil fuel sources: coal, oil, diesel. Nuclear power, hydroelectric dams, and solar wind all together account for no more than 20% of our electrical grid. So you're using fossil fuels, you're not saving the planet. But as I've said in my book, Climate Change, a Hoax of CO2, feel good about that because CO2 has nothing to do with global warming or the sea level rise. And here was a cute cartoon that appeared that kind of says it all. A big factory spewing out smoke that Al Gore detested, producing electricity, going to a transformer, going to an outlet, and then the person in an eco car, an EV bike, if you will, he is thumbs up that he is saving the planet and he doesn't realize it. Don't be naive. Okay, now I'm more of a scientist and anything. Most of my medical career has been about scientific innovations and such. But let's talk now about what I think is a critical issue here: the scientific limitations of electricity for replacing fossil fuels in cars and trucks. A lot of people don't realize it, and this shouldn't bother you, but pay attention to this because I think this is the bottom line, if you will. Electricity contains only 0.4 million joules per kilogram. Now, a joule is a universal measurement of energy, and zero point 0.4 is not much, and that's all electricity, whether it's AC or whether it's DC. Gasoline, in contrast, contains 47 million joules per kilogram. That's a difference of 117 times more. This is why a EV car or an EV truck can never be bigger than perhaps an Amazon Prime delivery truck, United Parcel Services truck, those smaller trucks. And even then, they're going to pay for it with an increased battery. So keep that in mind. That is the laws of physics that cannot be changed. So therefore, last slide I'll show you, EV vehicles will be limited to cars, even considering their noted problems. And they may not be universal in cars other than maybe a hybrid, which I think has a better concept by conserving electricity and not letting it go to heat from the internal combustion engine. But it's going to be limited to these small trucks that I discussed, the likes of Amazon and mail delivery trucks. It's not going to be able to power an airplane, of course. It's not going to have the ability to power a Mack truck, and it probably won't have the ability to even a small, what's called a two-trunk truck, a deuce and a half truck, because the truckers call it. So that's going to be the limitation. It's the size and it's due to the weight of the battery. And even one person suggests, well, what about outboard motors? Well, the battery it would take to do an outboard motor would sink the boat due to Archimedes' principle before it could ever move at all. So consider the weight versus the energy gained. That's the real conundrum that we're looking at. I'll conclude with that. Hope this has made sense to everyone, and we'll go on with the next one here soon. Thank you.